All right, Matt 2, here we go. We got lesson 2.3.4, similar triangle proofs. Now, on this lesson, I'm kind of combining two lessons, 2.3.3, the one before it, and this one. I didn't think that we needed to have two separate lessons. So the bottom problem will be from the previous section, or maybe it's this section. I can't remember. Anyways, moving on. So side splitter theorem. So Mark decided that the two triangles are congruent here. So you got the small triangle on top and then the bigger triangle. He's got some side lengths. So you might think, oh, we can try side angle side on this one or something like that. But we can't do side angle side because we don't know what this side length is on the big triangle, because this side length would be x plus 5. So we would only be able to try angle angle on this problem, and angle angle does work. Because at the top here, this is the reflexive property. Angle J from the small triangle is the same thing as angle J from the big triangle. So we have the reflexive property. And then since we have parallel lines here, we can use this as a transversal and prove that this angle JEA is congruent to angle L down here because those are corresponding angles. And when lines are parallel, corresponding angles are congruent. So the two shapes are going to end up being similar to each other. So he knows that they are similar by angle angle. Oh wait, this is congruent. That's not congruent, it's similar. Yeah, sorry. Typo. So how does he know? He knows that they are similar by angle angle. So he used the reflexive property, saying that angle J, oh, that was really bad. Angle J is congruent to angle J. So angle J from the small triangle is congruent to angle J from the other one. And then he uses corresponding angles. Using JEA, congruent to this angle L down there. We could have also used corresponding angles here, but remember, once we know that two angles are congruent, the third angles have to be congruent too. But we only had to prove two of them. So there we've got congruent by angle angle. Now to solve for x, since he wanted to find x, he did 4 over 6 is equal to 5 over x plus 5. Now what he's doing is he's taking the small triangle and comparing corresponding parts to the big triangle. So he's saying the small triangle here is 4, so that's where the 4 is coming from. And the 4 on the small triangle corresponds to this entire side, which is 4 plus 2. So really what he's doing is 4 over 4 plus 2 is equal to 5 from the small triangle, so I'm putting small triangle on top, over, and then this entire side length here is x plus 5. So that's what he's comparing them to. And this makes sense because the 4 does correspond to the 6, and the 5 corresponds to this entire side of x plus 5. Now we can use cross products for this one. So remember this is 6 right there. So I'm going to do cross products. 4 times x plus 5. Remember we have to distribute. So that would be 4x plus 20. And then 6 times 5 is 30. Subtract 20 from both sides, we get 4x is equal to 10. Divide by 4, we get 10 over 4, which is 5 halves. So now he knows what x is. Well, Janelle comes along, and she accidentally wrote 4 over 2 is equal to 5 over x. And then she got the same answer. Well, that's not supposed to work because she's not comparing 4 and 2 are from, 2's not like the corresponding part. 2's just a piece of the bigger triangle. But it ends up working on this one. So she's got 4 over 2 equals 5 over x. Cross products gives us 4x equals 10, and then divide by 4, and we get 10 over 4, which is 5 over 2. So she's getting the same exact answer. And so we have to think, is this an accident? Is this something that is just because of the numbers that we use that it ends up working on accident here? Or is this a new property? And it is a new property. It's called the side splitter theorem. So you'll notice that over here, we've got the side of the big triangle here has been split by these parallel lines. So in the side splitter theorem, when the sides of a triangle are split by a parallel line. When that happens, you can do what Janelle did. Janelle compared 4 over 2 to 5 over x. So the segments of the long side that got split, we can do this. So what she's saying here is that JA over AN, so that's the 4 over 2, is proportional to JE over EL. So the side that split, the two segments are proportional to the other side that's split. Now we're going to use algebra basically to prove that this is always going to work. All right, so here I'm going to start off by saying that A over B is equal to C over D. All right, and now I'm going to use algebra to prove that this is always going to end up working. All right, so in order to do this, I'm going to go back to what I was doing over here, comparing big over small, or small over big. Rough day today. All right, so if I do small over big, A corresponds to A plus B. So A over A plus B. And then C would correspond to C plus D. All right, so now I'm going to do cross products and see what we get. When I do cross products, I do A times C plus D is equal to C times A plus D. Did I say D? I meant B. Those letters are hard. All right, now I'm going to distribute. So I'm going to distribute here. I get AC plus AD equals AC plus CB, or BC. All right, do you notice on both sides of the equation we have the same exact pair here, AC here and AC here. So we're going to subtract AC from both sides. And what am I left with? I'm left with AD equals BC. All right, so for this one, I'm going to divide both sides by B. That leaves me with AD divided by B equals C. And now I'm going to divide both sides by D. And that leaves me with the D's canceling over here. A over B equals C over D, which is exactly what I've got right there. That's a side splitter. We just proved side splitter is always going to work using algebra. Now this only works for the split sides. You cannot use this shortcut when we have the parallel sides. What I mean by that is if you had, I don't know, well, let's just do this. If you had 4 and 2 here, and let me make up the numbers for this one. If you had 5 and x here, you cannot do 4 over 2 equals 5 over x. It only works for the split sides. For this one, you'd have to say 4 over 6 equals 5 over x. Okay, so side splitter only works on the split sides. It does not work on these parallel sides. All right, write the converse to the side splitter theorem. So the converse is, if the split sides are proportional, then these two lines are parallel. So the side splitter theorem says, if we have lines that are parallel, then the split sides are proportional to each other, 4 over 2, 5 over x. The opposite is, if you can prove that these two are proportional, then that would prove that you have parallel lines. So everything that we do in math, every rule of math, is something that can be written as a converse and still be true. All right, last one. This is actually from the last section that we're going to kind of skip. We've just kind of got a problem here. Tanya, she's taking a picture of her dad in front of Big Ben. So this is in England. And his head is blocking the top of the tower. So where she's taking the picture from is blocking the very top of the tower. And she thought she could use some measurements to estimate the height of Big Ben. So her camera is 2 feet above the ground. Her dad's 6 foot tall. She knows that her camera is 12 feet to her dad. And then her dad's 930 feet away from Big Ben. So she's going to use that information in order to find out how tall Big Ben is. And what we're going to do here is we're going to make triangles. If I make a triangle here, so I'm going to assume that Big Ben is perpendicular to the ground. Otherwise, it'd be tilting and probably wouldn't step. And I'm going to assume that her dad's not leaning. So it looks like we've got an angle here, an angle here. So this would be a small triangle right here. And then we've got a bigger triangle over here. And now we know by angle, angle, those two triangles are going to end up being similar to each other, meaning they're proportional. So we are looking for Big Ben. That is x over here. Well, actually, that's not Big Ben. X plus this 2 feet is Big Ben. So whatever we solve for x, we're going to have to add 2 feet to it. This distance is 12 feet. This distance is 930 feet. And then this height here, we've got 2 feet off the ground. So that means the remaining height is 4 feet. And now we've got a proportion that we can write. So we've got this small triangle here with the camera and her dad. And then we've got a bigger triangle with the camera and Big Ben. So the small triangle is going to be compared to the big triangle. They have to be proportional to them because we proved it by angle, angle. So in the small triangle, let's use this side first. We've got 12. And then we're going to compare it to not 930 because this is not side splitter. Side splitter is if we would use these two sides. These are not part of side splitter. Those are the parallel sides. So we have to compare 12 to 930 plus 12. which would be 942. So the entire length of this big side right here. So that'd be 942. Should be equal to 4. That's from the small triangle. And then over here I've got x. All right, we can now use cross products to solve this. So I'm going to do 12 times x is 12x. 4 times 942, I'm going to use my calculator, is 3768. And now I'm going to divide by 12 on both sides. So I'm going to take 3768, divide by 12, comes out to 314. Is that the height of Big Ben? No. That's this part of Big Ben. This part is 314. The entire height, we would, since the camera's 2 feet off the ground, we'd have to add 2 feet to find out what the height of Big Ben is. So the height of Big Ben is 314 plus those 2 feet. So it is going to be 316 feet tall. All right, that's all I got for you today. Math hard. See you guys later. Bye-bye.